Okay, so when we look at the quiz, the most commonly, one of the first commonly missed quiz questions had to do with finding the X and Y coordinates. So it says, hold on one second. It's being difficult. So find the X and Y intercepts. And do not graph. So the equation they gave us was y equals 5. So if you remember, y equals 5 is a vertical line. So how do I know that it's a vertical line? Well, remember, y equals 5 has to do with every y coordinate is going to be 5. So this is a horizontal line, excuse me. So if I were to make the graph, if I'm looking at every y coordinate is 5, let's go. We're looking at 1, 2, 3, 4, 5. So the first point is going to be right here, and that's the point 0, 5. And then we would have all the rest of the points here, right? Which would give us a horizontal line. So the y-intercept is the point 0, 5, but for the x-intercept, there isn't one. So we would just say there is no x-intercept. So it's possible we could have had the situation where what if we had a problem that had given us, let's say, x equals -2. Well, in that situation, that is a vertical line. And every x coordinate is -2. So in that situation, we would have an x-intercept of -2, 0. But for the y-intercept, we would say there is no y-intercept. So oops. I can't really access the chat today. So if you do have a question, just please ask it out loud. It's weird on my iPad. It doesn't really share nicely. So what questions do we have about this one?
Since there is no intercept, does it matter where you plot the points along the 5, or just that there's 2 on it?
So if you were to graph it, it doesn't, you want to make sure if it's saying like, okay, now graph the line, you would want to use the intercept first as one of your points. that 0, 5, but then the next point, it doesn't matter. You could do 5, 5. You could do negative 3, 5. You would just want to make sure that it has that y coordinate of 5. But when it's asking about the actual intercept, we're looking at for where it crosses the y axis. So we have to make sure that we list that 0, 5 part. Is that answering what you were asking, Elijah?
Yeah.
Okay, perfect. All right, so let's look at the next one. So we had solving a system of equations graphically. And so I'm going to have you try this one. This kind of follows in with what we just did. So let me get a new whiteboard. And so I've got negative 4x equals 20 and y equals negative 2. So I want you to graph those two lines. And the hint for the first equation is to isolate x. And then once you graph those two lines, I'm going to open the chat feature up so you can actually send me your solution. There is a solution, and I want you to send me what you get as a solution for these two. For anybody who, I have the chat window open over my whiteboard that I'm sharing. Are you just seeing the whiteboard, or are you seeing the chat feature as well? Anybody?
Just the whiteboard. I'm seeing.
Okay, perfect. Just wanted to make sure. Okay, so if like I said, I want to isolate x first. So I'm going to divide both sides by negative 4. And so dividing by negative 4, I get x equals negative 5. So if we, and we already have the y equals negative 2. So if we graph these lines, because that was what it was measuring, could you graph the line? So my first line, I'm going to graph in blue. So x equals negative 5. So negative 5 is right here on my x-axis. So this is a vertical line, right? This is x equals negative 5. And my second one is going to be y equals negative 2. So I'm going to switch my color to green. And there's negative 2. So I'm going to graph that line. Y equals negative 2. And then we can see the intersect is right here between those 2 points. or those two lines, excuse me, and that point is -5, -2. So you can see that just by using the two equations, it's telling us that point where they intersect, we have to have -5 as our x value and -2 as our y value, right? It's going to be both of those. So questions about that one? Okay. So our last one is going to be, we have this system, 3x plus y equals -8, and -6x equals 2y plus 12. And so we want to graph this to find the solution. Now remember, we have the options of, we can find the x and y intercepts for the two equations and just graph using that. If you can put it in slope intercept form, that's helpful too. I'm going to use slope intercept form, and so that's just going to be my choice. So in the first equation, I'm going to isolate y by subtracting 3x from both sides. So this is going to be giving me y equals -3x minus 8. Again, what information can I get from here? Well, my slope is this -3, which we write as the ratio of -3/1, right? Which we interpret as, we're going to go down 3 units, right 1 unit. And then the second piece is that my y-intercept here is -8, which means it's the point 0, -8, right? So if I were to graph this, let's first show the graph here. I'm going to use that y-intercept of -8 first. So I will graph my first line in green since the work for it is in green. So I'm going to 0, -8. And that's going to be there. Now my slope is -3, so I can come down 3 and write 1. Now it's possible that your graph might not give you enough space to do that. So what I'm saying is that if I look at the graph that was in Elon line, or not, excuse me, not Elon line, but what am I trying to say? In Pearson, it only went to -10. So if I were to graph using the slope, that's going to take me down to -11, right? It's going to give me a point that's down here. So the alternative that you can do here is that you can go up 3, but left 1. So you'll notice that going for this slope of -3, we can go down and to the right, but sometimes we won't have enough space. And so we need to do the opposite of both of those directions. It would be up 3, left 1. So for this line, to get my other point from -8, I could go up 3. So -7, -6, -5, and left 1. So we would have, again, -7, 6, 5. So we could have another point right here. And so that's another way that you can use your slope steps in order to get to another point. So since we're graphing by hand, it's always good to do a couple of them. So from this point of -1, -5, we could go up 3. So 4, -3, -2, and write 1 more. And because I'm doing this by hand, it's kind of rough, but we get something that looks like this, right? And so if we go to our other line, which we'll do in blue, okay, I want you to take that equation, -6x equals 2y plus 12, and write it in slope intercept form first. So if we write this in slope-intercept form, we need to isolate y. So we can start by subtracting 12 from both sides. And you're probably like, wait, Erin, why are you moving it to the left? All I have to do is isolate y. So this gives me negative 6x minus 12 equals 2y. If we divide all 3 by 2, we're going to get negative 3x minus 4 equals y. So now looking at this, I can tell that I have a slope, again, of negative 3, which should be giving you the idea of, oh, these are going to be parallel lines because their slopes are the same. And then this piece is going to give me a y-intercept of negative 4, which we write as 0, negative 4. So going to my graph, I'm going to go down to 0, negative 4, and then using my slope of negative 3, which remember is down 3, right 1, or we can go up 3, left 1. Both of those are going to give us the same slope. So I can go down 3 and right 1, or I can go up 3 and left 1. And yes, I know my graph is really rough, but we can see that these are parallel lines. So was one of the problems, I'm just curious, that you had with this, was it the fact that when you went to graph it, if anybody had problems with this type of problem, was it because when you went to graph that first equation, the graph didn't extend far enough? Like, did anybody run into that problem?
That happened to me twice.
Okay. So
But
yeah.
it took it as like you could go to the end and then up some. So if it was at the same slope, it would still take it as the right answer.
Oh, okay. Yeah, so being able to go back and forth with these two slope directions is going to be helpful. Predominantly, your problems will allow you to use that first method, which is down and to the right or up and to the right. But every once in a while, you're going to get something that doesn't give you enough space, and you're going to have to use that opposite directions in order to be able to have them match up. Because again, you can see if you were to draw a line here, it's matching that same slope, right? It's that idea that you're still moving those same number of units. Has anybody else run into a problem like this?
Yeah, I think I did the same thing and I couldn't figure it out. I was just like, oh yeah, it's past 10, so I don't know what they want me to do.
Yeah. You're like, you think I got nothing. I don't know
Yeah.
what you want.
And like some of those graphs are like, some of them are like 0.5 and some of them are 1 and some of them are really tight and some of them are wide, and it was all over the place.
Yeah, they are difficult, and unfortunately there's not really a better like, we can't control the parameters that tightly, unfortunately. I wish we could, but that's where, when I ask you to show your work, it's always a good idea to draw on your written work like, this is what it should look like. I couldn't get the window to show me all the points I needed, you know what I mean? So
Yeah.
then I can look at, oh, you know what's going on. It was just that you were limited by what Pearson was providing you. Okay, so those were the most commonly missed questions. Let me stop sharing my screen for 1 second so we can all look at each other. So what questions do you all have about the content? That's really close. You don't need to see me that close. Has anything come up in the homework that you guys want to go over?
I'm pretty good right now.
Okay.
Yeah, I think so.
Okay. Well, like I said, tomorrow I won't be able to go over that little piece of 4I, where we're putting the graphs into Google Sheets. I'll talk about that next week on Tuesday when I'm back in my normal office, but I will still go over 5A. And so we'll make that transition tomorrow to 5A. So we will still have class. It'll be on the weird iPad. I'm sorry. But thankfully we're at least able to have class and I'm not just canceling entirely. So any other questions for me before I let you go for today? We're good?
I think I'm good.
All right. Well, I'll see you all tomorrow. I hope you have a good rest of your day. And as usual, email me if anything comes up between now and then.
All right, thanks.
Awesome. Thank you.
Bye, everyone.
Bye.